Christina, I'm going to apologize now while I'm recording this, that I forgot to restart the recording. So if you need help with the workshop 3, we did it together. So I'll work with you on that and we'll get that straightened out. Let's see if
I was hoping to I can go through it again.
Well, she said she might contact one of you for some help if she got stuck. All right. I'm gonna real quick just make sure that we're on the same page. And
Okay.
while I picked on Jennifer when I started this, I'm gonna pick on Elise this time. Elise, give me a do you remember the difference between mean, median, and mode?
Oh Lord. Median, the middle number. Mode is the average, or is mean is
the average.
Mean is the average. Mode is the one that appears most often.
Very good. Which one do we use the most often in stats?
Average, the median.
The mean. The mean.
Oh, mean. I'm sorry. Yeah, sorry.
And what's a range?
The range is the range between the numbers, like between
the highest to the lowest.
The lowest. Okay.
What's the difference between a sample and a population?
Samples is a specific group of people instead of the entire population. You're sampling out which people you want to test.
Okay. I'm going to pick on both of you now. Give me an example of a population, then give me an example of a sample for that population, for some project that you might want to look at or something you've done.
So I would, if I'm just going through like PACU and going through my, what we talked about for our studies, mine was going to be on post-op nausea, vomiting. For surgical patients. My population would be all the surgical patients that come into the department, but my sample would just be narrowing it down to just bariatric surgeries.
So if you're looking at post anesthesia vomiting, what about somebody who had a gallbladder attack?
Well, I think that would be my population, right? It was any type of surgery, any person coming in, and then if my sample would be just narrowing it down to people.
The reason I'm asking you is, are bariatric patients reflective of your entire population?
No, it would be bariatric surgeries, like the patients that have gastric sleeves.
So I'm thinking all bariatric patients might be your population, and maybe a month's worth be your sample.
Okay.
Do you see the difference?
Yeah.
Because if you're narrowing it, if your sample is narrowed to one kind of surgery, you're not really doing all kinds of surgeries.
Right.
So your population can't be any surgery, because I assume you have different anesthesia for different surgeries.
Yeah. Okay, that makes sense.
Okay. I just had an upper GI yesterday. Let me tell you what I think of that stuff.
Oh.
Actually, I don't remember anything.
Well, that's good. You're not supposed to.
Don't remember anything. Okay, Elise, give me an example of a population and a sample.
Okay. Sorry, I'm thinking.
Okay, do you have any kids?
No.
Okay. Think back to when you were in high school. Your high school could be your population. Depending on what it is. If I'm looking at school spirit, that's just something silly, but then I would want to have a sample that would have all the different classes. Somebody from each of the levels. I wouldn't want to just pick the juniors, because I don't know how the freshmen and sophomores may feel. So you'd have to have one from every class, somebody from every class.
Okay.
So can you think of something along those lines, getting out of healthcare and think of something different?
So if like, oh Lord, if I'm like doing for like population like would be people who like ice cream, and then like my sample would be like different groups of people who like certain ice creams. Like they prefer pistachio, chocolate. I'm trying to think of something that's not here.
If you use your population is people who like ice cream, and your sample could be ice
just
cream
like
at a grocery store for a week. So you find out which different ones they like.
Oh, okay.
or like can your sample be like just teenagers?
If you want to do it, but again, if your sample is everybody, if your population is everybody, then you have to be reflective of everybody. So you need all those different ages.
Gotcha.
For me, I can think of lots of things that have to do with nurses. If I want nurses as my population, then I have to make sure that when I pick a sample, if I don't narrow down my population any, that reflects all different kinds of nursing. One of the problems with that for some research is if they don't narrow it, there's a lot of nurses who aren't in clinical. I've got faculty that teach a lot of theory. I have faculty teach a lot of clinical too, but they're not full-time in clinical. So they have a different perspective on clinical than somebody who's in clinical all day, every day. Does that make sense? Particularly if you get into the advanced practice nurses. If we're talking nurses, do we need to narrow the field? So for me, my nursing students, I might want to say nursing students in general, and then have some kind of survey that goes out throughout the country to gather data in about what their preferences are for preparing for the NCLEX.
That would be your sample?
That would be my sample. So I would ask 30 colleges in the country to have their graduating seniors tell me what they're going to do to prepare for NCLEX. I just have to make sure I geographically hit a broad spectrum. Does that make sense? Now, if I want to narrow my population to Illinois, nursing students in Illinois, what are they doing? It might, for me, it might make a difference in my population because it depends. Nationwide, men run about 7 to 8%. Now, St. Anthony's is about 10. So I'd want to run close to I want to get enough men if I can. If I do a great big group, I can pull more men into it. If I do a really small group, then I have to be careful because depending on what my sample is, I mean, I have room for men. Do I purposely want to exclude them? Not if I can avoid it. Do I want them to be my only people? That would not be reflective of my population. If I said, okay, I'm only going to pick 20 people and 7 of them happen to be men, that might be an issue. Now, sex may have any bearing on that particular question, but it could, different reflective on what different kinds of things they want to do. Does that make sense? So we've been through that. Let's talk about correlation again. I know this is a review for you, Jennifer, so we're going to let Elise pick up a little bit of this.
Take it.
If you have positive correlation, what does that mean?
That there's a relationship?
If one goes up, the other one goes up. And if one goes down, the other one. So if you're looking at elevators, they both go up and down at the same time. One may go faster than the other because the correlation is not perfect. If you have a negative correlation, what does it mean?
They go down. Oh, they go at opposite.
Got it. They go opposite. So if one goes up, the other one's going to go down and vice versa. Got it. Good. All right. Here's the hard ones that we started with. What's reliability?
That you're going to get the same answer.
Yep.
No matter what
So
you
if
do.
you retest it, you'll get the same answer. What's validity?
So I wrote down like you say you're going to get, you get what you say you're going to test for.
Yep.
So if you're testing for a certain thing, no matter how many times you test it, you're going to get the same thing. No, that's reliability. Well,
What you're measuring is the same.
what you're measuring is the
Just
same.
may not. Yeah, it just may not come out every time because it may not be a reliable test, but it is measuring what you say it's supposed to measure.
Okay.
All right. What's the null hypothesis?
But there's no difference.
Exactly right. That's the exact answer you want every time. What's the research hypothesis?
That there is a difference.
What you're trying to prove.
But, and we discussed this before you got on. Your research hypothesis really is whatever you're researching. Depending on your point of view, and that's when we talked about that mechanic. When I want to prove the mechanic wrong, my research hypothesis is that the mechanic can't do what he says he's going to do. When I'm the mechanic, I'm going to prove that I can do what I say I'm going to do. So there is some point of view in your research hypothesis. More times than not, what Elise first said is exactly right. More times than not, you are going to be able to make a change. Are you proving anything? When you run a test, what are you proving?
You're proving whether your hypothesis is right or wrong.
You're not proving anything. You're
Oh.
saying that you're statistically speaking, the data shows that this may, but we don't prove anything in statistics. I was telling Jennifer, I have a t-shirt that says statistics means never having to say you're 100% certain.
Oh.
We don't prove, we either accept or reject the null hypothesis based on the data that we are given. Okay. What does it mean when I say we're going to reject a null? Okay, we've decided I want to be able to show that my students will score better on their NCLEX if they take this particular study guide, if they work with that before they test. So what's my null hypothesis?
That there will be no difference whether they take the course or not.
Yep, exactly right. Now, if we're going to get technical, the scores, their NCLEX score before the NCLEX score for those who did take it and that NCLEX score for those who did not take the study guide will be the same. There's no difference. What's my research hypothesis?
That there will be a difference.
Not only that there'll be a difference, but that scores for those who took that will be greater. Now, the reason I'm pointing that out, if I just say it'll make a difference, is that one tail or two tail?
One tail. One tail is one direction or directional. I'm confusing it all.
Okay, if I'm only saying it will make a difference, it could be greater or it could be less. I'm just saying it'll make a difference.
So that's two tail.
That's two tail because it's two directional.
Yes.
If you can say it in a mathematical term that means using an equal sign or a not equal to, then it's a two tail. I'm saying for my research hypothesis, I want it to be positive. We're going to score higher. Is that one tail or two tail?
One tail.
That's one tail. Exactly right. Good. See, you guys are listening to me. All right, we know what the mean is. That's in the middle of our perfect little bell curve that we like to work with. And we have a standard deviation that we've calculated, usually having the computer do it for us because that's just too much work to do. So if my mean is 10 and my standard deviation is 2, if I'm one standard deviation out, what is it?
12.
Positive, negative.
Oh, if it's out, it'll be positive. It'll be 12.
If it's out either way, positive and negative. If I start out at 10 in the middle, and I go 1 standard deviation out either way.
You're deducting and adding to?
Yep. So it'd be
Yeah,
8.
8 and 10, or 8 and 12.
Yep. What percentage of my data should fall within that range in a normal, wonderful bell curve?
Oh, I gotta, that's
34?
Half of it.
Half of it?
That's the you had half of it.
14.
Oh,
34 is on one side, 34 on the other side.
So
68. If I'm looking at one
Oh.
standard
68.
deviation on either side, that's 68% of my data. You guys are getting it though. You're doing it off memory, but you're getting it because you're giving me the right idea. What's a Z-score?
The different. The result of dividing the amount of the raw score differs from the mean of the sample scores by standard deviations.
That's the formula.
Yes.
What does it tell me? Why do I want to know a Z-score?
Because we want to know the standard deviation between them.
It tells you how many standard deviations you're out.
Yes.
Yeah. So if it's not easy numbers to see, calculating a Z-score would be able to help you picture on a perfect curve where it would fit. And then you would be able to guess from there how much data is involved, or just where it fits in the big picture. What I try and do whenever I'm thinking of those is, remember I talked about coloring in what you're looking at.
Mm-hmm.
What do you want to know? And be careful what the question asks. It may be asking for everything on one side, or it may be asking for everything on the other side, or it may be asking for both sides. Good. You guys got it. Very good. Okay. We're going to move on to chapter 10 a little bit. After you read chapter 10, you will really like the cartoon on page 201. Sum of squares is one of the ways of calculating your errors. All right. For my class, some of the nitty-gritty stuff we're not going to get into. He does a nice, I want you to flag page 214. We're going to do several different ones that we're going to look at. But 214, as we start moving in the next couple of weeks into more tests, you're going to want to know, how do I know what test to run? How do I figure out what I'm supposed to be doing? He's got charts like this throughout the book that are really, really good. Okay, I'm going to flip back a couple pages. All right, on page 205. Significance level. You see that top third of the page? This is important because you have to determine how much risk you're willing to have. What's the percentage that you're willing to go on your confidence? Nobody's ever 100%. Okay. In medicine, in business, we can have more luxury of dealing with risk than you can in medicine. Does that make sense? Okay, I may lose a few dollars, you lose a few lives. So it's more important that you minimize risk in healthcare than I minimize the dollars so much. Significance level is what we're going to compare our answers to when we do some of the calculations to see how much risk it is the chance that this is all due to randomness or it's really due to what I'm doing. Did whatever test I run based on the, all right. I wanted to know if implementing a physical therapy program, a particular physical therapy program, would decrease the amount of pain my patients was having. Okay. And we did pain scores before and after. Before the therapy and after the therapy. So I want to know, how do I know what's significant, if it's statistically significant in the difference in scores? Okay, if the scores come out identically the same, there was no. But how many times is that going to happen? If the scores do change, but is it enough to really make a difference? The calculations we'll do will tell us, was the change that we made in that physical therapy program, were the scores related to that, or is it a chance? It's just based on chance. No matter what, you know, you could have done nothing and you just gotten the same scores, or you could have done, you know, just had somebody stand on their head and then would have got the same scores. That's what it's asking. Does significance is how much risk are we willing to take? And then we compare it after we get done to how much the calculation says was due to chance. For business, it's usually around 10% or 0.10. For non-life-threatening medical, it might be 5% or 0.05. The more serious it is, the more likely it is to go down to 0.03 or 0.01. Now, does that make sense why that's that way?
Because you're taking less of a risk.
You're not willing to take the risk when it's life-threatening. When you're doing drug testing, if you're doing it on animals, you might be willing to start out with a higher risk, but once you get to doing it on people and going to clinical trials, you're not likely to want to do a whole lot of risk in there. You want to know that what you're doing is making a difference and then that's not due to chance. Does that make sense? Okay. If you look on 207, now he says this is the most important table in the book. I disagree with him on that. There's a reason it's important. If you're a researcher, it's really important. We talked that you could reject the null hypothesis, but maybe you're wrong. Maybe there's not enough data. Maybe there's something else going on. This is what could happen with a null hypothesis. If you reject it, but it was really true. Let's say your null hypothesis was really true. If you accepted the null hypothesis, and your null hypothesis was true, then you did it right. Correct? Mm-hmm. But if it was really true and you rejected it, there's an error there. It tells you it's a type 1 error. A researcher would know off the top of their head it's a type 1 error. If you ask me, I have to go back to the book and look it up every time because I forget because I don't do it often enough. If the null hypothesis was really false and you accepted it, then you made a type 2 error. So all this table is telling you is that you can sometimes accept one that you shouldn't have, or sometimes you can reject one that you shouldn't have. One's a type 1 error, one's a type 2 error. You need to go back to the drawing board and look at those if you find out that it should. That's why so many of the, particularly in medicine, you have more than one set of tests. You might test it now, but somebody else is going to retest it a month from now to make sure that they get the same kind of results. Whether it's maybe you tested it only on 10 people this time, but you're going to test it on 30 people next time, and then 100 people, building a bigger sample base. The idea is you can accept or reject a null hypothesis based on our standards that we're going to set in the class, but it might be wrong because there was something that we didn't see. Whether it was a clerical error, whether it was sampling error, or any number of different things. You can't be always 100% right. Okay. So then the book discusses what a type 1 and type 2 error is. I just want you to know that there are errors. We know that that's going to happen. Don't get paranoid about remembering which one's which. Okay. Now, why do I care about significance? When you run a lot of data, there's, okay, I ran ACT scores for this high school, then I ran ACT scores for this high school. How do I know the difference in the average ACT score is really statistically significant? When I run the test, it will give me a p-value, and I can compare it to what I'm willing to say is just due to chance. And if my p-value is less than what I set it for, that means it was actually less chance than what I was willing to take. That's a good thing. Then I can reject my null hypothesis. Before you start any testing, you determine what amount of chance you're going to take. You can't decide after the fact. That is unethical. So you start beforehand. I'm willing to take, on my ACT scores, I can do 10% because I don't have any, nobody's going to live or die over this. So I'm willing to take a 0.1 as my p-score. Anything over 0.1 tells me that my null hypothesis is right and not my research hypothesis. Because it means anything over 0.1 means it's due to chance and not due to what differences in the high schools. If it's less than 0.1, then that means that's less than, I was willing to take a 10% chance, but it was only 9. So maybe there is a difference between the two high schools. And I could reject my null hypothesis. My null hypothesis is what? If I'm looking at ACT scores between the two high schools, what would my null hypothesis be?
That there's going to be no difference.
Right. My research hypothesis could either be that there is a difference or that I really expect one to be higher than the other, just depending on what I'm looking at. But the important part is your null hypothesis is what you're testing against, always. Your research hypothesis can be different. Your null hypothesis is always what you're testing for. Because you're saying there's no difference, I'm willing to say that I'm willing to accept up to 10% that is due to chance, but beyond 10%, no, it's not due to chance. They really are. There's no difference between them. Okay. Let's do another one. Let's say you have 2 different test groups. You have a treatment A and treatment B, two different groups. Now, I have absolutely no idea whether A or B is different, is going to be better or not. We're starting from scratch, and I just want to see what's going to happen. So my null hypothesis is there's no difference between the, we'll do pain score, no difference between the average pain score between test group A and group B when they get done with their therapies. I'm willing to take 5% chance that it's due to chance alone and has nothing to do with what therapy we're using. That's just random. My P-score, when I get done with my calculation, ends up being 0.04. 0.04, I'm sorry, 0.04. So what does that tell me? If my P-score, if I determine in advance that I'm willing to take up to 5% chance, and it's actually only 4 when I score it out. So it did better than being just randomly by chance. What do I do with my null hypothesis?
Reject.
You reject your null hypothesis because with 4%, we think there's a good chance that it actually did have to do with which therapy we were working on. A way to remember this, one of my students came up with years ago. If the P is low, meaning lower than your established significance level, if your P is low, the null must go. That makes sense?
Mm-hmm.
So from a medication point of view, warfarin on one side, and what's one of the other blood thinners?
Eliquis.
Eliquis. So we have warfarin and Eliquis. Gotta try and think of something we're going to measure with it.
Like decreased DVTs or something.
Okay, so we'll have patients on those will have fewer returns to the hospital on one over the other. Okay, what's my null hypothesis?
That there will be no difference between either of the meds.
Right. So on this particular one, what do you think we should use as a what we're willing to take for chance?
Low.
Keep it low. Probably 0.03 or 0.01. Let's say it's 0.01. That means I'm willing to say I'm only willing to take 1% chance that it's due to randomness and not due to one of these two medications. So if I score a 0.05, what do I do?
.05 is higher, so it's you're going to accept
it.
Yep, fail to reject the null hypothesis. Yep, exactly right. You fail to reject it. And that's a terminology that most statisticians use. We tend to say accept, and I'll catch myself once in a while doing it. But it should be fail to reject, because you should reject the null hypothesis or you fail to reject it. Now I'm going to ask you a question. Okay, it was 0.05. Well, it's 0.05 is no big deal. Why don't we just change our expected value to 0.05 and then it comes out.
That's not ethical.
Not ethical. Very good. What happens?
That's all I got from this.
What happens when it's 0.01? When your calculated p-value and your p-value you're willing to accept are exactly the same. That depends on the research. Some research labs will allow for it, and some research labs will automatically tell you you can't use it. That It doesn't happen very often because when you're dealing with data to come up, all you gotta do is have 0.011 and then automatically tells you can't use it, right? So let's review this a little bit. You determine in advance how much risk you're willing to take, that whatever study you're doing, the results are based on chance and not on what you're doing. Let's use a 0.05. We're willing to take 5% chance that it's due to randomness and not on what we're doing. If we calculate it out, that the chance of it being due to randomness is really 6% and not 5%, then we don't want to reject the null hypothesis because there's a chance that it's not due to what we're doing. It's not due to what we're looking at in the study. But if the calculated p-value is less than 0.05, that means, say it's 0.04, that means that's only a 4% chance that it's due to randomness and not what we're working on. And we were willing to take a 5%. So 0.04 is good. We're going to reject the null hypothesis because we think there is we think there's good data that shows that it's there was a difference. Jennifer's looking at me like, sure.
I think I just have to read through those pages and
That's okay.
maybe just replay your video again, this again.
And we will go through these because these are the p-value concept. Every test we run will calculate a p-value. We will determine whether we accept or reject the null hypothesis for every test based on that p-value. There are other ways to accept and reject null hypotheses, but for what we do in this class, this is the golden rule. So we will do this from here through the rest of the class. Does that make sense?
Mm-hmm.
Okay. Now,
Is it okay if I finish watching the recording because I have dinner's ready? I'm sorry.
nope, that's more than okay.
All right. Thank you guys.
Yep.
Bye. Thanks.
Okay. The other thing I want to talk about is I'm going to stop after I get done with scientific notation for tonight, and then we'll do one sample t-test next week or z-test next week when we're in class together, because I think it's easier to do that in class.
Okay.
Only thing I want to show you is scientific notation. Let me pull up. Do you remember what scientific notation is from your classes in science, usually in chemistry?
No.
Okay. Most people don't because they don't see it every day. So let me be able to pull up. Okay. If I do 3 divided by 7. Oh, didn't do that. Shame on me. Now I'll have to do a different one. Oh. Oh, my brain just quit. All right, let's do. Okay. You see these 4 hashtag marks?
Yes.
That just means it's too small for the space. So we're going to bring it out a little bit. Well, I want it to be a number. That doesn't help any. And then it changes it. All right. That's a normal digit, right? If I had a calculation that took it out, say 15, 16, or innumerable decimals, it can't handle it. It just doesn't know how to do that. If I had a number that said 3.4 E7. Right. That means you can move your decimal over. Oh, it changed it on me. I'm sorry. It means you can move your decimal over. It's one of those things that Excel will do it on you without giving you warning. And if you're not prepared for it, I'm trying to see if I can come up with a example in the book that has it so you're prepared. No, I don't. I'll pull one up before we go to class next week.
Okay.
And we'll do that. Do not worry about week 4 homework till we finish the week 4 discussion. But do the discussion board because that's something that you can do. The week 4 discussion board is looking at the real world stat example that they give on page 220 and just writing what you think of it, your opinion, and talking about it. So don't worry about the assignment, and I'm going to put a note out there. Let's send an email to all of you right now. Inbox to M300.
I don't know if I lost you or you lost me.
Yeah, you froze on me for a little bit.
Yeah. Okay, go ahead. Sorry.
I can hear you, but you're still frozen.
I'm frozen.
We've had problems on and off today. All right. We'll worry about scientific notation next week when we can get together.
Okay.
And I'll have an example to show you. Do the discussion board, but don't do the assignment for week 4. We'll do the assignment together in class.
Okay.
And I'll send an email out to everybody.
Okay.
So you just need to take your notes and finish week 3 assignment, but you should have all of that. Your week 3 discussion board's 1 question and your week 4 discussion board's 1 question.
So upcoming week 3 discussion, week 3 assignment.
Yep.
2 assignments. Okay.
Now there's 1 and there's upload assignment here, I think.
Oh, gotcha. Well, it says upload assignment 3 here, upload assignment here.
Oh, well, that's because I didn't do it right.
Okay.
So let me go back out and correct that.
Assignment.
All right. I got interrupted and I probably did it twice. Oh. Upload assignment 3 here. And you're seeing another upload?
So when I go, I don't see anything on my modules, but when I go to assignments, upcoming assignments, week 3 discussion, upload assignment 3 here, upload assignment here.
Do the upload assignment 3 here.
Okay. And then
I'll go back and delete that other one. It's when I was starting it and I didn't like it and I deleted it on the module side, but it didn't get deleted from the other side. So I'll get rid of that so it doesn't confuse anybody.
Okay.
Doing it right now. Okay. All right, I've checked on the discussion board. That's been corrected. Everything is up to date on that. I'll send an email out to everybody to let them know what to do in case they're confused. And then I'll also include how we'll handle the midterm next week.
Okay.
Does that work?
Yes.
Deep breath.
Just a lot, at once, but it'll be
It
fine.
is.
Yeah.
But we're getting there.
Yeah.
All right.
Okay.
Don't hesitate to call me if you have questions as you're reading stuff.
Okay, great.
Okay?
Thank you so much.
You're welcome.
Good night.
Okay, a quick